In this video, we are going to talk about graphing. We're going to do an intro of graphing trig functions. So first, we're going to talk about some vocabulary. One of the things that you need to understand is that these are periodic functions. A periodic function is a function that repeats exactly in regular intervals called cycles. And you guys have probably seen sine and cosine for sure before as a periodic function. Trigonometric functions are periodic. The period is the length of the cycle. Periods can start at any point on the graph. So the period is like this top, let me zoom this in a little, is this measurement from here to here. So it's from one peak to another. That's the period. Oh, we can't see that. Let me make it bigger so I can write, and then when I zoom out, you'll be able to read it. And then the amplitude is half the distance between the minimum and the maximum. So in a standard graph, it's from the x-axis to the bottom or the top. So what it's saying right here is like, here's the bottom, here's the x-axis. So it's measuring that is the amplitude. So let me zoom this in so I can write it. Okay, so there we go. So we've got the period is distance left to right, amplitude is distance top to bottom. So the unit circle is very closely tied to sine and cosine in particular. I will put a video of a sine and a cosine being drawn by a unit circle so that you can witness that greatness. But you use the unit circle values. So we are going to be switching back to radians for graphing sine and cosine, or graphing any of these trig functions. X represents the angle theta in standard form, and y represents the corresponding trigonometric value. So think about that. If you look at 0 on the unit circle, the sine is 0. So sine starts there with 0. Remember, sine goes with the y value, so that should make sense. If you need to, look back at the unit circle. And then at pi over 2, which is 90 degrees, y is 1, or sine is 1. I do not understand why this graph is spread out so much. It's completely unnecessary for it to be this tall. It would look better if it wasn't. And then when we get back to pi, which is 180, sine is back to 0. When we get down to the bottom, it's -1. So the graph is at -1. And then when we get back to 2 pi, which is 360 degrees, we're back at 0. And that graph, if we went backwards around the unit circle, then we would see this in reverse. So we would go down to 270, up to 180, up to 90, and then back to 0. So this is the sine curve. I'm going to attempt to make this beautiful. I probably will fail. So it's going to continue in that direction, continuing the wave, if you will. And on this end, it's going to continue up to 1 and before it turns around. So that is the sine curve, and it has an amplitude of 1, okay, because it goes down to 1, or down to -1, up to +1, and then the period is 2 pi. So think about that from, if I went from here to, well, I can't use that one because there's not another one on there. Well, I could start here. So from here to here, you are counting 2 pi. So your first pi, would be to here, and then your second pi would be, so here's a pi, and from here to here is another pi. So it's 2 pi altogether. Okay, I'm going to take all that off because that's a lot of business. All right, for the cosine, remember the cosine goes with the x on the unit circle. So think about what is x's value when you are at certain places on the unit circle. So when you are at 0, your x value is 1 because it's off to the side, you know, all the way over to 1 on the x-axis. And then as you start around the unit circle, x is actually getting smaller because you're coming back towards the y-axis. So at 90 degrees, it's at 0 because it's on the y-axis. At 180 degrees, which is pi, that's -1 because it's all the way extended the other way on the x-axis. And then as you move down to negative, or to 270, where it's, you know, down at -1 on the y-axis, but it's 0 on the x-axis. And then for 2 pi, which is back at the starting point, you're back at +1. And then it's going to look the exact same. It is reflected about the y-axis on the other side. So we're going to go, think about going backwards around the unit circle. So down to 270. Let me take these off. Down to 270, 180, 90, and back to 0. All right, so again, it is a wave. So there shouldn't be any sharp turns. And then it's headed back down from there. Okay, so they are the same amplitude. This one also goes up to 1 and down to -1, so it's an amplitude of 1. The period is still 2 pi, and you can see that if you look here to here. So here's 1 pi, 2 pi. So they're exactly the same. The only difference is sine starts on 0, cosine starts on 1 when you're talking about the y value. So it's like you took, for the cosine, it's like you took the sine curve and just moved it back a half a pi. The graph of sine and cosine are called waves because they have a wave-like rolling appearance. And you probably know that. You've seen that in science class for sure. Changing the amplitude and period, if you're given y equals a times sine b theta, or y equals a times cosine b theta, where theta is in radians, the amplitude is the absolute value of a, and the period is 2 pi divided by the absolute value of b. So that one's a little bit trickier to think about. So the period is that length between the waves. And so it does take a little bit more to move it than the amplitude. The amplitude, you can move that up and down pretty simply. So in this next little area, they just want you to identify the amplitude and the period. So think about that the amplitude is the absolute value of A, so absolute value of 3 is 3. And then for the other one, you have to use the little formula. So you have 2 pi is your formula, and then the absolute value of 2 is 2. Well, 2 over 2 simplifies, and you're just left with a period of pi. On the next one, you have some fractions, but that does not mean that you do anything differently. So we're going to have the amplitude is just the absolute value of 3 halves, which is 3 halves. And the period would be 2 pi over the absolute value of 1/3, which is 1/3. So basically you're trying to divide by 1/3, which is the same as multiplying by 3. So this equals 2 pi times 3, which is 6 pi. All right, so that's the intro to that. I'll come back with the next page.